In this lesson, we're going to learn how to solve quadratic equations that are written in Vertex form. As an algebra student, you've heard of PEMDAS. We use PEMDAS, or order of operations, when we evaluate expressions. It's a particular order that we have to follow. When we evaluate expressions, we begin by working in the parentheses, then deal with the exponents, followed by multiplication and division, and finally addition and subtraction. When we solve equations, we use the inverse of these operations. In other words, we use SADMAP, which is PEMDAS backwards. SADMAP is very simple. When solving an equation, first deal with the subtraction and the addition. Then deal with the division and the multiplication. Next, deal with the exponents. And finally, deal with the parentheses. In today's lesson, we're going to use SADMAP in order to solve equations that look like this. This is a quadratic equation written in Vertex form, and SADMAP actually makes this very easy to work through. The first step says to deal with subtraction and addition. In this equation, we have subtraction of 27. The inverse is to add 27 to both sides of the equation. When we do that, we now have 3 times x plus 2 squared equals 27. You might notice that there is a plus 2 inside the parentheses. We're going to leave that there for now because we deal with the parentheses at the end. The second step is to deal with the division and the multiplication. On the left-hand side of the equation, we have multiplication by 3, and so we will divide both sides of the equation by 3. The 3's will cancel out on the left, leaving us with x plus 2 squared. On the right-hand side, we have 27 divided by 3, which is 9. We're now ready to move on to the next step, which is to deal with the exponent. We have an exponent of 2 in this problem, x plus 2 squared. The inverse, or opposite of squaring, is taking the square root, and so we'll take the square root of both sides. This is an important step, and you have to be very cautious here. On the left-hand side, the square root and the squared will cancel out. On the right-hand side, we have to put a little plus and minus in front of the square root. When we're dealing with equations, it's important to note that we're not only paying attention to the principal square root, but also the negative square root as well. On the left-hand side, we now have x plus 2 in parentheses. On the right-hand side, we have positive or negative 3. Now it's time to deal with the last step, the parentheses. Inside the parentheses, we have plus 2. The inverse of adding 2 is subtracting 2, so we will subtract 2 from both sides. When we do this, we have x equals negative 2 plus or minus 3. That gives us two possible solutions. X equals negative 2 plus 3, which is 1, or x equals negative 2 minus 3, which is negative 5. These are the two solutions to the equation, also called the roots, the values which make the equation true. Let's take a look at another example. 5 times x minus 1 squared minus 80 equals 0. Do you think you can solve this equation using the last one as a guide? If so, please pause the video here and see if you can find the solutions. Let's work through the example to see what the solutions are. We follow SADMAP. In SADMAP, the first step is to deal with addition and subtraction. We have subtraction of 80, so we add 80 to both sides. That gives us 5 times x minus 1 squared equals 80. The second step is to deal with division and multiplication. We have multiplication by 5, so we divide both sides of the equation by 5. When we do that, we're left with x minus 1 squared on the left equals 16 on the right. Next, we deal with the exponents. We have a squared power, so the inverse is to take the square root. On the left side, the square and the square root cancel out. On the right side, I have to put the plus minus in front of the square root. That leaves us with x minus 1 equals positive and negative 4. The final step is to deal with the parentheses. In the parentheses, we have minus 1. The inverse of subtracting 1 is adding 1, so we add 1 to both sides. That gives us the solutions x equals 1 plus or minus 4. Be careful, this does not equal plus or minus 5. We have to write 1 plus or minus 4 and then look at the two solutions. X equals 1 plus 4, which is 5. X equals 1 minus 4, which is negative 3. 5 and negative 3 are the solutions or roots to the equation. Now let's look at another example where something a little funky happens. The equation looks very similar to those we've solved already, and we're going to follow exactly the same steps, except there will be a little twist in the middle. We already know that we follow SADMAP, and we begin by dealing with subtraction and addition. In this case, we'll add 150 to both sides, leaving us with 2 times x plus 6 squared equals 150. Then we'll deal with the division and multiplication. We have times 2 on the left-hand side, so we'll divide both sides of the equation by 2. We're left with x plus 6 squared equals 75. So far, it looks identical to everything we've done, and it has been. Now let's deal with the exponents. We have the exponent of 2, and the inverse of squaring is taking the square root. So we take the square root of both sides. As usual, the square and the square root will cancel out on the left, and we'll put the plus or minus in front of the square root of 75. That leaves us with x plus 6 equals the square root of 75. But 75 is not a perfect square. We have to simplify that radical. We look for the largest perfect square that goes into 75. That number is 25. 25 times 3. So the square root of 75 is 5 square roots of 3. Therefore, we have x plus 6 equals positive or negative 5 square roots of 3. Now the final step is to deal with the parentheses. In the parentheses, we have plus 6. The inverse is to subtract 6. X equals negative 6 plus or minus 5 square roots of 3. We can leave the answer like this, or we can write the two solutions separately. X equals negative 6 plus 5 square roots of 3. X equals negative 6 minus 5 square roots of 3. These often feel very uncomfortable to algebra students. We're not used to thinking of numbers with radicals in them. If it makes you feel more comfortable, you can approximate the solutions by looking in your graphing calculator. But leave your answer in exact form with the square roots in it. Any decimal you would put is simply a rounded solution, which is not exact. And now a word of caution. Please be careful when working with square roots. You know that you cannot combine unlike terms. If you had 2 plus 5x, you would never say that was 7x. Similarly, if you have 2 plus 5 square roots of 3, that is not 7 square roots of 3. You can think of the 5 square roots of 3 like 5x. You would never combine it with the number 2. And similarly, you cannot combine things that have square roots attached to them unless both items have the same square root. Let's end today with one last example. This is for you to try, and it will have a square root to simplify. Can you find the roots or solutions of the equation 3 times x minus 4 squared minus 96 equals 0? Please pause the video here and come back to compare your answer. Let's compare answers. We're using SADMAP. The first step is to deal with subtraction or addition, so we add 96 to both sides. The second step is to deal with division and multiplication, so we divide both sides by 3. The 3's will cancel on the left, and on the right-hand side, we have 96 divided by 3. This gives us x minus 4 squared equals 32. Next, we deal with the exponents. The inverse of squaring is taking the square root, so we take the square root of both sides. Remember to be careful. The square and the square root cancel out on the left, and on the right we have to put the plus or minus in front of the square root of 32. We're now left with x minus 4 on the left and the square root of 32 on the right. Because 32 is not a perfect square, we have to simplify that. The largest perfect square that goes into 32 is 16. 16 times 2. That means our simplest form of the radical is 4 square roots of 2. So x minus 4 equals plus or minus 4 square roots of 2. The final step is to deal with the parentheses. The inverse of subtracting 4 is adding 4, so we add 4 on both sides. The solution is x equals 4 plus or minus 4 square roots of 2. Remember, be careful, you cannot combine that 4 and 4 square roots of 2. We can leave the solution like this or write the two solutions out. X equals 4 plus 4 square roots of 2, as well as x equals 4 minus 4 square roots of 2. These are the solutions or roots of the equation. For those curious, the decimal approximations can be found using the graphing calculator. 4 plus 4 square roots of 2 is about 9.65685. 4 minus 4 square roots of 2 is approximately negative 1.65685. But it's best to leave your solutions with the radicals in exact form. And now you know everything you need to know in order to solve a quadratic equation in Vertex form. Remember, you can learn more in Mr. Dorey's Algebra Handbook, available at www.doreypublications.com.